All right, here we go. So now hopefully the board will work the entire way. So a couple of things about this week. So we've got 2 more lessons to do. Wednesday we've got a review. Thursday is your test day. This is also the end of the quarter too. So it's kind of a big one because grades aren't due until Tuesday. So that test will go on your quarter 1 grade. Okay?
Wait,
Next Tuesday is the grade. Yeah. Okay? So, kind of a big deal, this test, because then it boosts some grades, or it could also hurt some grades. Hopefully it's more of a booster than a hurter. Okay? So, we're going to start in your white note packets on page 39. Before you leave today, if you didn't turn in Friday's worksheet that we gave as homework, or that I gave as homework on Friday, make sure you get that turned in today. Okay? So we're going to start on page 39. I want you to create a graph and an explicit equation in number 1 and number 2. If you need to make yourself a table, go ahead and make yourself a table. Then in number 3 and 4, I want you just to simplify those down. Okay? Questions, comments, concerns? Let's do it. Oh, let's see. So that we're going up by 3, so that's 3x minus 1 for our equation. Yes?
I got 3 on minus 1.
Did you use that then? That works. As long as your variable matches what you defined it as. Yep. Questions on that one? Yes, sir.
Are we allowed to use y, or are we still supposed to use like?
You could use. I'd let you use y here.
Do you want it? Which one do you prefer?
Depends if it says function notation or not. That one's a curve, because now we're increasing by 3 times. Two times 3 to the x minus 1 power. Questions on that one?
Is it different just because it's geometry? Oh wait, never mind.
Because of that word right there.
I'm confusing myself now.
You want us to draw the line through it?
What do you mean?
Like, I just. put
The curve?
Well, yeah, I just put the points on. Instead of
Okay.
line, or instead of the curve.
Okay,
That's fine.
that's fine. Gonna distribute in this negative 10. So then that's going to be 24 minus 20x minus 80 plus 62 plus 7x. Then you gotta combine like terms. So I got an x term there and I got an x term there. Those two combine to be negative 13x. I've got a number term here. I've got a number term here, and I've got a number term there. 24 plus 62 is 86. Minus 80 is just 6. So I get negative 13x plus 6 there on the simplification. Had to double distribute on this one. Okay. So then now I've got 3 x's. 14x minus 5x is 9x. Minus 9x is 0x. So that means that term is totally gone. Okay. Positive 7 minus 3 is 4. So this one simplifies down to just be 4. Questions on either one of those two?
Hey,
Okay. All right. So Grandma Billings is quilting, and she's got to make her squares for the quilts. Okay. So in pattern number 1, she uses 3 squares. Agree? In pattern number 2, she uses 5 squares. In pattern number 3, she uses 7 squares. And in pattern number 4, she uses 9 squares. Do we agree with everything that I've just said so far? Agree? Okay. All right. So Zach noticed that he saw the pattern developing, and he came up with an equation. B equals 2n plus 1 is what he came up with. Does Zach's equation fit the pattern that Grandma Billings is making?
Yeah.
How do we know?
You just input 1.
Okay, input 1.
And then you're trying to find.
Okay, so 2 times 1
Equals 2
plus 1,
plus
3 works out. Input 2, 2 times 2 is 4, plus 1 is 5. Input 3, 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. So it works out. Agree? Okay? All right? I will be honest with you. This, anybody want to take a shot at how to say that name?
Sion.
Sion?
Sony.
Sony? I'm gonna call them because I don't know male, female. I've honestly never seen that name
I think
before.
it's C1.
Sion.
Sion?
Sione.
Sione? Either way, we're just gonna call him S. Okay? So S took a look at the pattern, and S came up with this. 2 times the quantity and minus 1, then plus 3. Does S's pattern fit Grandma Billings?
No. I don't think.
Why not?
1 minus 1 is 0.
Yeah, it does.
Times
But yes,
2.
it does. Yes,
Okay,
it
so times 2 is still 0,
Yeah.
plus 3 is 3. 2 minus 1 is 1, times 2 is 2, plus 3 is 5. 3 minus 1 is 2, times 2 is 4, plus 3 is 7. 4 minus 1 is 3, times 2 is 6, plus 3 is 9. So it fits. Okay? Alright? So, what can you tell me about those two equations?
Same.
They should be the same, right? Okay? So if they should be the same, then here in number 2, we should be able to make sure that they wrote the similar or equivalent ones. So let's take S's. B equals 2, open parentheses, n minus 1, plus 3. Okay? Zach's was B equals 2n plus 1. Right?
Yeah.
So if I want to show that they're equivalent, I got to do some math tricks on S's. Okay? So I'm going to simplify S's and see if it comes out with Zach's. So I would first distribute this 2 into both of those spots. So then that's going to be 2n minus 2. And then I still got that plus 3 out there. Well, I can now combine these two. Negative 2 plus 3
1.
is 1. So this becomes B equals 2n plus 1, which is now the same as Zach's. Agree?
Absolutely.
Now, Marcus joins the conversation, and Marcus has come up with 2 more potential rules for Grandma Billings' squares in her quilts. Okay? So what I want you to do is I want you to show me if Marcus is like Zach and S and that they're equivalent. Okay? So you got to do that twice. So show that Marcus's first equation is equivalent to the other 2 that we've already shown, and then make sure that his second one is equivalent to the other 2 that we've just shown. Go for it. So all 3 have written the same equation. They just wrote it in different ways. Okay? Alright? Now, if we're thinking about this, let me scroll back up just a little bit to see if I can get them all. Actually, I can go right from here. Okay? If we're thinking about this in terms of a chart, if we had the pattern number and the amount of squares that Grandma Billings was using, okay? We had pattern 1 had 3 squares. Pattern 2 had 5 squares. No. Yeah, 5 squares. Pattern 3 had 7, and pattern 4 had 9. Right? Okay? Well, Zach just gave us the general one. Zach said if we would have went back 1 to pattern 0, instead of adding 2 here, he subtracted 2. So Zach went to pattern 0 and found that we were adding, or we had just 1. Okay? S went and looked at this one. Marcus went and looked at these two and made his equation from those two. Okay? All right? So, skipping to number 5. Okay? So now, what we're working towards doing is we are working towards, first, we got to find the rate of change. Okay? So the first thing that you got to do now is you got to find that rate of change. And there's many ways to find the rate of change. Okay? We are going to call that rate of change from now on, we're going to call that rate of change the slope. Okay? Then, for the longest time, for probably, going on almost 9 weeks now, okay, you've been taking, how do we say it? Oh, we said it as, like, no, not that way. How do I want to say this? I'm going to put it in function notation. We've been saying f of x is equal to the term value minus or plus, I should say, the rate of change times x minus the term number. Whoa! The term number, right? We've been doing that a lot. We started it in Unit 1, and we continued it in Unit 2. Well, now that is really just something called the point slope form. So if you have the slope and you have a point on the line, you can come up with the equation. You might want to write this down. I know you're mad at me because I woke you up, but this is not a place to sleep. So don't be mad at me because you were sleeping in my class. Okay, we're still taking notes here. Okay? F of x is going to become y. The term value is going to become y sub 1. Okay? I'll explain this here in a minute. The rate of change, we said now is the slope, so that's m. X is x, and the term number is the x part. So these here come from the point that you are given on the line. Okay? So those two come from the point that you're given on the line. The slope is the m value, okay? The rate of change. Okay? And then lastly, we're going to simplify that so that everybody gets the same answer. Now, okay? And when we simplify point slope, we get the slope-intercept form of the line, which is y equals mx plus b. Now, all of that information is located also on your toolkit. Okay? It's right here up in the upper left-hand corner of your toolkit. Okay? So the slope-intercept form is there, and the point-slope form is there for you to use in both of those instances. Okay? So, with that being said, what is the rate of change here in letter A? We went plus 7 on the on the y's, and we went plus 1 on the x's, right? So that means that my slope then is going to be 7 over 1, or just 7. Okay? So we first found our slope. Okay? Step 2. Which one do you want to use? Which point do you want to use? Top, middle, or bottom? Top one? Okay? Alright? So if we're utilizing the top one, then it's going to be y equals the term value plus 7, that's my slope, or my rate of change, times the quantity x minus my term number. In this case, it's negative 15. With me so far? Do we ever write minus a negative? Just put a plus there? Okay. Then we distribute. Uh, 7 times 15.
105.
105? Then I can combine my number terms, right? And so I get y equals 7x plus 137. And that's the equation of the line that would fit that down. Questions on that? You now do letters B and C. Find me the equations of those two lines that fits that data.
Yeah.
Right? 28 times 4 is 112.
I got
28 times 4 is 112.
it. Yeah. Wait. 4 times.
Oh, I see.
28 times 4.
112.
I did 2 different ones.
Now, here's the best part.
They both were.
All three of them should get you the same answer.
They still were.
spot check on letter B. I got y equals negative 4x plus 182.
Yep.
Yeah?
Yep.
Julius' face says different.
Because Julie's got y equals x plus b.
I did not get why some of my notes. Those are my notes that I was taking.
That's
I was
awesome.
Listening.
I have a question. How
What's
does it
up?
go from a negative to a positive?
What do you mean?
Oh, negative 4 times negative 28. Negative.
Negative times a negative is
Oh, negative 4. Okay.
that's how.
Who's Al? How are they doing?
Last one I got y equals 5x minus 110. Smart choice. As long as you understand it. How do I do that same method off of a graph? What do you got?
Find the slope, you just do rise over run.
Okay, we can do rise over run.
2 points.
Okay. So I rose 2. And I ran
7.
7. So that's going to mean my slope is 2 sevenths. Yes?
Yep.
Okay. Which point do you want to use? Left or right?
Left.
Left one?
Yes.
Okay. So then that's going to be y equals 1 plus 2 sevenths times the quantity x minus 1. Yes?
Yep.
Okay. Distribute.
Plus equals 2 7x. Yeah.
2 sevenths times x.
2 7x.
2 sevenths x. 2 sevenths times negative 1. 2 sevenths times negative 1.
2 7.
Negative 2 sevenths.
Oh yeah. Negative. Yeah.
If I want to combine those two terms, what do we have to have?
Common denominator.
Common denominators. So what is 1
Sometimes.
in terms of sevenths? 7 over 7. Then we're minusing 2 over 7.
5 7.
So that gives us 5 sevenths. So this gives me y equals 2 sevenths x plus 5 sevenths. Notice what isn't in this problem.
Whole numbers.
Decimals.
That's
Okay? Leave stuff in fraction form. Okay? The sooner that you embrace the fractions, the easier your math life will be.
so are we? Oh, never mind. I asked you that question.
Glad I could help. Okay? What I would like you to do now is I would like you to do numbers 8 and 9. I pushed this button down here. I'm that good.
Would you accept y equals -1
That's what I have.
x plus 2?
Mhm. I mean, oh, something's not stirring the Kool-Aid there.
I can stir the Kool-Aid.
What does that mean?
-3.
Oh, that's what
Two
I got.
negatives cancel out, which makes
Oh, I
it
got
plus
that.
sign. So you get negative.
It's-
But yeah, you get +2.
That's
We
what I
plug
got.
it.
Yeah, it's +2 minus negative.
Oh yeah, yeah,
Yeah,
yeah, yeah, yeah. Because I'm going up. Yep. Got inside my own brain there for a second. Okay. Homework tonight is going to be, so let's get out your homework packets and let's go through it right now.